welcome back to my YouTube channel. So we are solving the last question of Biweekly Contest 1 to 5 of LeetCode. So let's start the question. There exists undirected tree with n nodes from 0 to n minus 1, and we're given a 0 index 2D integer array which is denoting the edges u comma v, no issues. Now you're also given a positive integer k and a zero indexed array of non-negative integers nums of length n, where nums I represent the value of the node numbered I. Okay, so this guy wants the sum of values of the tree nodes to be maximum, for which he can perform the following operation any number of times. So he can choose any edge and then he can update the values by doing the XOR with k. Okay, so if we take this example 0, 1 and 2, and this node 0 has a value of 1, this one has a value of 2, and this one has a value of 1. So 1 plus 2 plus 1, 4. So now they have changed, they have taken this edge and they have done the XOR. This is also 1, this is also 1. 1 XOR 3, k is given 3 is 2. So these all three became 2. 2, 2, 2, that is 6. So there's one thing that needs to be cleared before doing this problem. Let me get you through a graph in this. So suppose I'm trying to change, this is a tree that I've got. Now there are two things. One is we can change any node, and second, the total number of changed nodes, by change I mean doing XOR with k, should be even. Now how I came with this conclusion, there's no need of using edges here. I don't know why they've given the edges, that's just for the confusion part, just to create a tree. So there's no need of edges. So suppose I want to change these two, suppose 0, and suppose I want to change 3. Now this is easily possible. How? What I can do is I can start with, suppose initially 3 is not done. I can take this edge 0 and 1, and I can change 0 and 1 both. Now next time I can take this edge 1 and 3. Now for this, when I'll do XOR with k again, it will come back to its original state, and this will be changed. And how this will come back to its original state, if you see, if I do any XOR, suppose I take a x XOR x, x XOR k. Now next time also I am doing x XOR k. So now this time you see that it's already we have already done the XOR operation of this x with k. So k XOR k is again 0. So my x will become x again. So this will become to its original state. So we need to believe that always we will be able to change even number of nodes, and we can change any node, not just this. We can even change, like suppose I want to do these two as well, or let's just take this only. See, now we have got 3 nodes. We can't make this happen by doing any operations. We can't make this happen. You can try any way out, but I can make this happen. Yeah, so 0 and 3 can be done 0 1 1 3. Now for 6 and 2, first I'll do 6 and for 6 and 7, first I'll do 6 and 2. Okay, now I'll do 2 and 5. So 2 will be reverted to its original state and 5 will be changed. Now 7 I've already changed, it was originally like this. So now 5 and 7, 5 will be reverted back to its original and 7 will be changed. So with this you can try with any number of any form of tree. We can always change even number of nodes. We can't ever change the odd number of nodes. So our main idea behind this would be to loop through, or you can see the code and then you'll get the fair idea. We can loop through all the numbers in the nums array, and we can find the difference between the original number and if we do the operation on that node. So this is the difference. If the difference is greater than 0, that means we have to change it. The number is getting increased. So what we'll do, in sum1 we'll add this, change the number, and we'll also add the difference to our profit array or a list. And if after doing the change operation or the XOR operation we are getting the number decreased, in that case we'll add it to sum2 and we'll add it the absolute value of it to the loss one. Now later on what we can do, we can sort the profit array also and the loss array also. Now as we can see, our final result would be sum1 plus sum2, right? So now what we'll do is, profit contains the differences of the nodes that we have changed, and as we can see here, we can only change the even number of nodes. So if we have changed the even number of nodes, in that case we can directly return sum1 plus sum2, because sum1 already contains all the nodes for which the operation has given the increased value, and sum2 contains the original ones. Now in case we have got we have changed odd number of nodes, then in that case what we can do is, we have two options. First one is, like, we can unchange one node, or what we can do is we can change one more node. Now what we do, like suppose it is like this, we have changed 4 also, so this is not possible. So what we can do is, in this case, one thing is I can convert this 1 also to XOR operation, then it is even number. This is possible. Or the other way round is, I can suppose like unchange any one of the nodes. That case also we'll get even number of operation. Now what we need to check is, in this case, sum1 plus sum2 minus first value of the profit. Here what we are doing is, we are unchanging one node to its original value. If we remove the difference from it, then it will come to its original state, and we want to remove the least profitable. The least profitable only we'll unchange, so that we get the maximum profit with us. Or the next option is, we change one more node to the XOR operation. In that case we'll have to decrease or reduce this sum1 plus sum2 by the loss, and we'll also take the least loss in this, right? Sum1 plus sum2 is the answer, and we'll take the least loss that we are getting from all of our losses from our array, and in that case we'll reduce our sum by that loss. That means now we have changed our one more unchanged node to XOR operation, and this is only possible if our loss size or the loss array contains any element. Or if our loss array doesn't contain any element, in that case we'll only have to unchange one node to that is least profitable node from that, in this case. So this is how we came to this conclusion. Yeah.